Welcome to IT Career Institute. So this is our fourth video of the series where we are solving the chemistry paper of WebJEE 2022. So in this video we will be dealing with the last set of 10 questions. So I hope you have watched the previous 3 videos and you have gone through all the questions and their solutions. I hope you have understood, and if you have any problem, please feel free to mention it in our comment section below. So let's start with our first question in this video. This is the 31st question here. Let CRMS hydrogen is the RMS speed of hydrogen at 150 Kelvin. At what temperature the most probable speed of helium will be half of CRMS hydrogen? Okay, so for solving this question, first of all we should know the basic formula of root mean square speed, which is the full form of RMS square speed, that is denoted in short as CRMS, is given by root over of 3RT by capital M, and the most probable speed, that is CMP, most probable speed, which is denoted as CMP, is given by the formula root over of 2RT by capital A. Now in the first line, CRMS of hydrogen is the RMS speed of hydrogen at 150 Kelvin. So let T1 be 150 Kelvin so that we don't have to write 150 again and again. So CRMS of hydrogen at 150 Kelvin will be given as T1. T1 stands for 150 Kelvin and NH2. Now what is the molecular weight of hydrogen? 3RT1. Molecular weight of hydrogen is 2. H2 is 2. So this, let it be our equation 1. Next it is said that the CMP of helium is at a different temperature. So let the temperature be T2, which we actually have to calculate. So T2, for T2 CMP at T2, let me write it here, at T2 CMP of helium will be 2RT2 by molecular weight of helium, which is what? For 2RT2, molecular weight of helium is 4. So this is my equation 2. So let me write the upper portion. Okay. Also there is a condition given to us. At T2, it is basically at T2 they want the temperature, we have to find a temperature where the most probable speed of helium will be half of CRMS H2. Okay, so CMP, so at T2 we can write it like this: CMP of helium should be half of CRMS H2, right? So we already have find out the value of CMP and the value of CRMS hydrogen is denoted as equation 1. So let's put the respective values there. So CMP is this root over of 2RT2 by capital 4. Oh, I'm so sorry, not it's just 4. That equals to half. CRMS hydrogen is root over of 3R. T1 is what? 150. So let's put the value here, divided by 2. So let's wrap the lower portion. Now we just have to solve this, nothing else. So squaring both the side, this will remove on squaring both the side will remove the square root, right? So 2RT2 by 4. Now on squaring, this half will also be squared. So 1 by 4 into 3R into 150 by 2. So 4 will cancel out from both the sides. R will cancel out from both the sides. So we are left with T2 equals to 3 into 150 by 2 into 2. This another 2 will come down in the right hand side. This will come out as 102.5, which is the correct option is, this is in Kelvin, so the correct option is option B. So 32 question is, the correct pair of electron affinity order is. So we have to find out the correct pair. Okay. So here what are the elements that we have to deal with? Oxygen, sulfur, fluorine and chlorine. So basically in group 16 oxygen and sulfur comes up, and in group 17 we can find fluorine and chlorine. Now we know down a group electron affinity order basically basically decreases. Down a group in periodic table, electron affinity order decreases. So oxygen's electron affinity order should be greater than sulfur, and fluorine's electron affinity order should be greater than chlorine. But in case of halogen series, in case of group 17, there is an exception. All the other elements follow this trend, but chlorine basically has the highest electron affinity. Why? Because for having the highest electron affinity means what? It must have the capacity to intake excess electrons, right? So this fluorine being small in size cannot accommodate the extra electrons, but chlorine bigger in size as compared to fluorine can accommodate the extra electrons that are coming up. So basically chlorine exhibit maximum electron affinity in group 17. Rather, chlorine is the most the element which is exhibiting the most electron affinity among all the elements in the periodic table. So the correct order will be, this won't be the correct order. Chlorine actually has the greater electron affinity than fluorine. So which is the correct order? Oxygen greater than sulfur, and where is it? This one. Sulfur is less than oxygen, that is oxygen greater than sulfur, and chlorine is greater than fluorine. So option D is the correct option. So next question is 33. The product of the following reaction is. So we are basically provided with the reagents and the substrate, so we have to predict the product. Okay. So first of all, in the first step, we have to react with magnesium in the presence of dry ether. So basically, if the reaction takes place with magnesium and there is a haloalkane provided, a halo compound is provided to us, so basically Grignard reagent will be produced. Grignard reagent will be produced. Now there are two options. The magnesium will be inserted between a carbon and a halogen. Now there are two halogens are given, chlorine, bromine. So the magnesium will be inserted in which side? In between C and Cl, or in between C and CBr. So in this case we have to consider the bond strength. Now CBr bond strength is weaker as compared to CCl bond strength. So CBr bond will cleave first. So the Grignard reagent will be produced with the bromine part in the Br. Now we know after the Grignard reagent has formed, there takes place an Coulomb, that is the inherent polarity changes. Now this magnesium has delta plus, and with respect to magnesium, carbon now will bear a delta negative charge. Now in the second step, what we have to react with? 4-chlorobenzaldehyde. Now what's the structure of 4-chlorobenzaldehyde? It looks like this. The para position, there is a chlorine and there is an aldehyde group in the para position with respect to chlorine. Now this delta negative carbon atom will attack in the electron deficient carbon center of the carbonyl, and when this attack will take place, this pi bond of oxygen will open up, thereby resulting in the formation of O minus. Now this O minus will take up a proton, because in the third step we has aqueous ammonium chloride in the medium. So O minus will take up a proton from the medium, thereby forming OH. So how will the final product look like? This is the final product, Cl. Here it will be CHOH, and then it will be bonding with like this. Here it is Cl. Basically, this is our product. So this matches with which option? See, it matches with the option A. This is the correct option. So the next question 34 is the product of the following hydrogenation reaction is. So benzene is reacting with hydrogen. So addition of hydrogen will take place, right? So we have already seen what is the hydrogenation reaction. So there are 3 double bond. So basically 3 molecules of hydrogen is basically required under this similar condition to give you a cyclohexane, where all the double bonds have been substituted with hydrogen atoms. Okay, so for a benzene to undergo complete hydrogenation, we need 3 molecules of hydrogen, but in this reaction we are being provided only with 1 equivalent. That is, for 1 benzene we are being provided only with 1 hydrogen. They are telling that only 1 hydrogen, but what happens is, in a benzene, for 1 equivalent, people might think double bond will interact. One of the double bond will get hydrogenated and maybe all the benzene will be converted into like this. Only one double bond is being removed, but that's not the case, because whenever benzene is going to get hydrogen in its surrounding, then whatever hydrogen it's getting, first molecule will take up basically 3 molecules of hydrogen. However, 1:1 ratio, we are being provided with 1:1 ratio, but still they will be taking 3 molecules of hydrogen from the medium. Okay, so likewise all the benzene each of the benzene will take up 3 molecules of hydrogen, thereby forming cyclohexane. Now after a certain time, since we have taken the ratio of hydrogen less, we have taken 1:1 ratio, so after a certain time the rest of the benzene will remain unreacted, they won't be hydrogenated. Okay, so what's the correct option? So for one benzene we require, or rather 3 hydrogen molecules are required for hydrogenating one benzene. Right, for one benzene. So one hydrogen molecule will be like what percentage of benzene will be hydrogenated? That is given by 1/3 into 1, that is 0.33. So 0.33 percentage or 0.33 part of benzene will convert into cyclohexane, and the rest, that is 0.33 minus 1, 0.66 will remain unreacted. So which is matching with our answer is this. 0.33 equivalent of benzene has been converted into cyclohexane and the other 0.66 is remain unreacted. So C is the correct option. So the next question is 35. Pick the correct statement. We are given with 4 options and we have to pick the correct option, right? So the option is relative lowering of vapor pressure is independent of capital T, that is temperature. Option B is osmotic pressure always depends on nature of solute. Option C is elevation of boiling point is independent of nature of solvent, and last option is lowering of freezing point is proportional to molar concentration of solute. So basically let's start with option D. It is telling lowering of freezing point is proportional to molar concentration of solute. So it's basically wrong because it is proportional to molal. It is wrong, it is proportional to molar concentration, right? Molar concentration. So D is not the correct. Next is elevation of boiling point is independent of the nature of solvent. Basically it's independent of the nature of solute. Okay, not on the solvent. It depends on the nature of the solvent. Next is osmotic pressure always depends on nature of solute. Now osmotic pressure, elevation of boiling point, lowering of freezing point, all these are colligative properties. These have to depend on the number of solutes and not on the nature of solute. That's why it's a colligative property, right? So it doesn't depend on the nature but on the number of solute. Okay, and the option A is relative lowering of vapor pressure is independent of T. Basically it's correct because vapor pressure depends on temperature, but the relative lowering of vapor pressure, that is P0 minus P by P0, that the difference, because if I change the temperature, both P0 and both P0 and P will change to similar extent, but the difference will remain the same, right? So basically option A is the correct option. The next question 36 has come under MSQ, that is more than one option may be correct. Okay, so in this question it is said during the preparation of ammonia and Haber's process, the promoter used is or are. 4 options are given, so more than one option may be correct. So basically what's Haber process? That is the reaction between nitrogen and hydrogen to give you ammonia. So it's a reversible reaction. We have already studied Haber's process. And what's the catalyst? Fe2O3. What's the promoter? Molybdenum or mixture of alumina, L2O3 and K2O may also be used. Either of these two may be used at a temperature of 400 to 550 degrees Celsius and at a pressure of 1000 atmosphere. This reaction is being carried out. So the two options, there are 2 options correct, option B and option C, molybdenum or mixture of alumina and K2O. The next question is 37. The correct statement about B2H6 is or are. This is also has come under MSQ, that is more than one option may be correct. So first of all we should know the structure of B2H6. Diborane. So basically the structure of B2H6 is like this, where each of the boron are sp3 hybridized, and basically overall the molecule is diamagnetic. So see here, the option B is given paramagnetic, so it is wrong. Option B is not correct. Next it is given it contains 3-centered 4-electron bonding. Basically boron and hydrogen form 3-centered 2-electron bonding, because 3-centered are involved and there are 2 electrons that are resulting in the formation of this bond. So 3-centered 2-electron bonding is present, so this option is also wrong. Now all boron atoms are sp3 hybridized. I already said all the borons are sp3 hybridized, so this option is correct. And there are 2 types of hydrogen present. Yes, this is also correct, because these are called the bridgehead hydrogens and these are called the terminal hydrogens. Okay, so there are 4 terminal hydrogens and there are 2 bridgehead hydrogens. So 2 type of hydrogens are present, so option D is also correct. Question 38. Which of the following would produce enantiomeric products when reacted with methyl magnesium iodide? So 4 options are given: benzaldehyde, propiophenol, acetone and acetaldehyde. First let me draw all the structures. Now what's the structure of benzaldehyde? This is nothing but this CHO. Okay. Propiophenol is this one, benzene. Then there is a C double bond O, and there is CH2, CH3 attached with it. Then there is acetone, CH3, C double bond O, CH3, and finally the acetaldehyde, CH3, CHO. So which will produce enantiomeric product when reacted with methyl magnesium iodide? Now what is methyl magnesium iodide? It's a Grignard reagent, right? So if I have to react it with benzaldehyde, what will produce? Methyl magnesium iodide is basically reacting. So magnesium has delta plus, methyl has delta minus, which will attack the delta plus center of the carbonyl, because carbonyl is electron deficient. So this pi bond will open up. So finally what will be the product? C. Basically here this is O MgI. And here CH3 has attacked, that is methyl group has attacked, and the hydrogen will remain as it is. So see, if on attacking this methyl group in this carbon center, this carbon has become chiral, because the carbon has 4 different groups in 4 of its hand, right? So this is a chiral compound. So whenever a chiral compound is produced, it has a probability that both D and L isomers will be produced. Now these D and L isomers are mirror images to each other, and the compounds which are mirror images to each other are called the enantiomers. So that's what we have to find out, which of these compounds will produce enantiomeric products. So see, benzaldehyde is actually producing enantiomeric product. So by following similar mode of mechanism, what will be the product here? In case of propiophenol, this is our propiophenol. So oxygen will open up and will bind with MgI, and the hydrogen will remain. The hydrogen will get attached with the carbon, and there there is no hydrogen, I'm sorry. The methyl will attack and the methyl will get attached to the carbon, and there is the ethyl group. So see, here also the carbon center is chiral. So here also both D and L isomers will produce, hence this will also give enantiomeric product. Next check out this one, acetone, CH3 C double bond to CH3. These on getting attacked, this oxygen will become OMgI, and another hand will have a methyl group, because it is being attacked by a methyl. Now there are 3 methyl group in carbons 3 of its hands, so it's not chiral, so it won't give enantiomeric product. Similarly, CH3 C double bond OH on being attacked by a methyl group methyl will come here, and this will be OMgI. This is also not chiral, because this carbon has 2 methyl group in 2 of its hands. So this will also not give enantiomeric product. So which are the 2 correct options that we have got? That is option A benzaldehyde, and option B is propiophenol. So the next question 39, this also has come under MSQ. So basically here the reaction is being given and you have been asked the above conversion can be carried out by which of the conditions. So here we can see in this reaction what's happening. See, there is a double bonded O in the substrate, and in this case the double bonded O has got reduced in the product and 2 hydrogen has taken up its place. Right. So basically a reduction reaction has taken place. So the first condition is given to us is zinc mercury couple in presence of concentrated HCl. This is the condition for which reaction? Clemenson's reduction. So via the help of this reagent we can carry out the above reaction. Next condition is given hydrazine in the first step, and in the second step sodium hydroxide in ethylene glycol. So this is the condition for Wolff-Kishner reduction, and this also can help us to carry out the above process, Kishner reduction. In the third case, here a thiol is given in place of acidic medium, and in the second step it is being reduced by hydrogen and nickel. So this is the condition for Mozingo reduction, and via the help of this condition also we can carry out the above process. But with the help of bromine water we cannot carry out the reduction process. Basically bromine water is used for addition of bromine to an alkene. Basically for that purpose bromine water is generally used. So basically these 3 options are correct. So we have come to our last question, question 40. So which of the following statements are correct? So the first option is given, pH of a solution of salt of strong acid and a weak base is less than 7. It's wrong, because strong acid and a weak base, basically the strong acid is in the form of a salt. So that's not basically contributing to the pH, but what is contributing? Weak base. So basically it's like alkaline in nature. So it should be greater than 7, not less than 7. So this is not the correct option. Option B is pH of a solution of weak acid and weak base is basic if Kb is less than Ka. This is correct, because if like pH of a solution of weak acid and weak base is basic only if the Kb is less than Ka, that is the dissociation constant of base is less than dissociation constant of acid. Next is pH of an aqueous solution of 10 to the power minus 8 molar HCl is 8. It is also correct, because see, how do we get pH? pH equals to minus log of concentration, right? So minus log of what's the concentration given? 10 to the power minus 8. So if we solve it, this minus 8 will come before, and log 10 is what? 1. Log 10 is 1. So this is 1, and minus will come out as plus 8. So it is 8. So option C is also correct. The last option is D. Conjugate acid of NH2 minus is ammonia. This is wrong, because the conjugate acid of ammonia is basically NH3 plus. Right. So this is also wrong. So the correct 2 options are B and C. So we have come to an end of this series where we had solved WBJEE Chemistry Paper 2022. So if you are interested in joining our chemistry classes, which we held for class 11, 12 of all the boards, as well as for every competitive exams like GMains, Advanced, and then there comes NEET and also WBJEE and other competitive exams as well. So if you are interested, please contact us. Join IG Career Institute for cracking all these exams that you are going to appear for, and you may contact us in the like via the details. All the details of our the contact details are given in below in the description box.